Okay, today we're going to talk about congruent figures, and we're going to go over the Common Core State Standard 8G2. Understand that a two-dimensional figure is congruent to another if the second can be obtained from the first by a sequence of rotations, reflections, and translations. So that's one part of the standard that we're going to go through. And the other part is that we're going to, when I'm given two congruent figures, you should be able to describe a sequence that exhibits the congruence between them. Okay, so the vocabulary is congruent, equal, position, and orientation. And the first thing we're going to do is go over the properties that change with certain transformations and ones that don't. So there are three properties that we're going to look at. Position, all right, and that is literally just the coordinates of the vertices. The orientation is the coordinates of the vertices relative to each other, okay, or the position of the vertices relative to each other, and the polygon and the size. Okay, so those three things we're going to look at. Do they change under the transformations to the left, or do they not change? So for translation, the position, yes, the position does change. So in this picture, that's a translation, and so you can see that M and M prime have different coordinates. So yes, the position changes. Now the orientation is looking at the vertices and how they sit with each other, relative to each other. So to answer this question, see how N right there is down, and it's to the right and down from M, and N is also to the right and down. N prime is right 2 and down 1 from M. So if I can use the same description to get from one vertex to the other in the original figure and in the new figure, then the orientation hasn't changed. So if I'm going from M to L, I would go down 1, 2, down 2, and left 2 in the original figure, and from M prime to L prime, the same thing would happen, down 2, left 2. Okay, so the orientation of this has not changed. And the size in a translation does not change. In a reflection, so the next picture is a reflection. The position, every position changes except if the point is on the line of reflection itself. So first, if we look at B, C, D, this triangle right here, these C and C prime have different coordinates. So C and C prime have different coordinates. If the point that we're reflecting was actually on the line, so if I were reflecting like a triangle that looked like that, I'd get a triangle that looks like that, and that point would not change. So yes, the position changes unless the point is on the line of reflection. The orientation also changes. So if I'm describing in the original triangle a situation to go from vertex B to C, I would say that I would gonna go right 3 and up 1. But from B prime to C prime, that has to reverse. I have to go left 3 and up 1. So since these aren't the same description between the vertices, we can say the orientation has changed. The vertices, how the vertices sit according to each other or relative to each other, has changed. And again, the size does not change with a reflection. Okay, the next one is a rotation. And the position of the coordinates do change, except if the point is on the center of rotation. So let's say we're asked to rotate a figure like this, and I would rotate it 90 degrees counterclockwise. The point, if it were on the center of rotation, would not change. But otherwise, yes, the positions of the vertices do change. The orientation also changes, but the size does not change. Okay, and with a dilation, the position changes, but the orientation does not change. How the vertices sit according to each other or relative to each other does not change. And this is the only, if you look down this column, it's the only transformation that makes the size change. Okay, so keep this in mind because we're going to eventually have to describe how to get from one figure to the next. Okay, so to define congruency, when two geometric objects are congruent, it means that the measures of all parts of those figures are equal. So if I said quadrilateral, or this is a polygon with 5 sides. If I said that this one was congruent to this one, it would mean that all side lengths are equal and all angles corresponding, and all angles, I'll put in parentheses, not that all angles are equal, but all corresponding angles are equal. Okay, so this angle that makes up this, that would be equal to this, for instance, and you put the little 1 hash mark there. N in the original one is the same thing as E in the old one, so those are equal. That's what I mean, all corresponding side lengths. Okay, so when I say that two geometric objects are congruent, I mean these two things. All parts are congruent. All right, now the learning objective, or the Common Core State Standard, described two situations. So the relationship between congruence and a series of transformations can go both ways. So going from congruence to a series of transformations, if I start knowing the figures are congruent, then that means you know automatically that you can find a series of transformations that will lay one on top of the other. Okay, and we're going to go over this situation first. So let's start with that situation. Okay, if I tell you automatically that these things are congruent, if I know these two things are congruent, and I ask you to find a series of transformations that brings one on top of the other, then what I'm looking for is the transformations. Okay. So I've labeled, since I know that these are congruent, I've labeled A and A prime similarly. Now let's think about this. The orientation has changed from this figure. Okay, so from the original figure, from A to B, I would go down 2 and right 3. But from A to B, I go down 3 and right 2. So from A prime to B prime, I would go down 3 and right 2. So I know the orientation has changed. Now let's just go back to that chart for a minute. Okay, the orientation changes with reflection and rotation. So either a reflection or a rotation had to have happened in order for that orientation to change. So let's go back to that. All right, so let's try to do, it looks to me like if it were, you could reflect it here and then you could reflect it here to get it into that quadrant. Or let's see if we can do a 180-degree rotation. Okay, let's see, let's look at the coordinates. So A is at, I'm just going to pause the video and write down all the coordinates real quick. Okay, so I just paused the video and now I wrote down all the coordinates on there. And it looks like it wasn't a rotation because it would have to have been a 180-degree rotation. But we know with a 180-degree rotation, that just takes coordinates and makes them both, it keeps their position and makes them both negative. But it looks like all these coordinates have both switched and become negative. So, So this might actually be a combination of transformations because I know that if I reflected it twice, if I took 3, 7 and reflected it twice over first the y and then the x, it would get that point and then it would get this point, which is not the point I have. So what if I tried to do, maybe I reflect it and then rotate it, maybe I reflect it over, let's see, if I reflected it over the x-axis, I would get A here, and I would get D here, and then I would get C and B, and then if I rotated it, it looks like A would, yeah, it looks like I could do that. So it looks like if I rotated it 90 degrees after that, A would become there, B would rotate 90 degrees, be there. Okay, let's try to do that with what we know about the coordinates. Okay, so let's just try one of these coordinates. Let's try 3, 7 first. 3, 7. So what I'm suggesting is reflection over y-axis and then a 90 degrees counterclockwise rotation. So if I reflect it over, let's say y-axis, let's make a little chart here. This would become -3, 7. And then if I reflected it, or sorry, if I rotated 90 degrees, that would switch those around and make the x1 negative, and that would get me exactly where I want to go. All right. So if I did that with 6, let's try it with one more point here. If I flipped it around the y-axis here, and then rotated it, that would get me those coordinates. They would be switched around and both be negative. So the series of transformations would be reflection over y-axis, followed by a 90 degrees counterclockwise rotation. Now I wonder if we could have done that in a different order. Like if I did the rotation first, let me try this, -7, 3, and then if I did reflection over the x-axis, I would have negatives would change the y. So I could actually have also done that. So there's two transformations that could have occurred. So I could have done the one here in purple, and then I could have also done a 90-degree rotation first, as well as followed by a reflection over the x-axis. So there's actually two answers here. Two answers would get you from A to A prime, and from all the original coordinates to all the original prime coordinates. Okay, so that deals with sort of the first question. If I tell you that two figures are congruent, then find the series of transformations that will lay one on top of the other. The second one is, if I'm asking you if you don't know they're congruent, then what you can do is, if you can find a series of transformations that make one lie on top of the other, then you can conclude that they're congruent. Okay, so given that there are some transformations, then they are congruent. So this is going both ways. Given that you have congruence, you can find a series of transformations. Given that there's a series of transformations, you can show that they're congruent. So that's what we're going to deal with next. Okay, so another way to define congruence is that if a figure can be reflected, rotated, or translated, notice the transformation that's not included here is dilation, and they can lie on top of each other, then the two figures are congruent. So the question here is, are these two figures congruent? And I got this from our textbook here. And notice that A and X, for instance, are not, X is not labeled A prime, because the question is, are they congruent? So you can't necessarily label them with primes because you don't know if one came on top of the other. So in the textbook, they describe a series of transformation that's going to let you see that they are congruent. But let's just notice something right here. So it looks like A, B, since those look like this side right here, okay? And this, it almost looks like a right triangle. Actually, it looks like kind of an isosceles triangle here. So if A and B are the same, supposed to be the same sides, just think about what changed here. So it looks like the orientation changed, because if I go from A to B, that would be the same as going from X to Y. A to B would go right 2 and up 1, and X to Y would go down 2 and left 1. So the orientation changed. Going back to our graph, our grid system that tells us which changes the orientation, remember the reflections and rotations change the orientation. So we know that something's been reflected or rotated. So the first thing that they try in this picture is they try a rotation, or they try a reflection. So they reflect it over the y-axis here, and they get this figure. And then it looks like it's been reflected again, because your B and your A are not in quite the same place. So they reflect it over the x-axis again to get step 2, and that's the orientation is correct for step 2, but it's not in the same position. So if you want to just change the position, so let's go back here. If you want a transformation that just changes position, and not, so translation just changes position, but it doesn't change the orientation. So going back to this figure right here, if you want to change this triangle's position, then you can translate it down. Okay. Now, the fact that you arrived at 2, so if you translate that down, you would arrive, it would drop right on top of that one. Now the idea that because you can describe a series of transformations, so the transformations here are reflection over y, then reflection over x, then we translate, looks like, okay, after we have that we have to translate down 1, and that's it, just down 1. Because I can describe to you a series of transformations that drops the original triangle right on top of the other triangle, we know that we can conclude that triangles A, B, C and is congruent to triangle X, Y, Z. Okay, so since I found this series of transformations, I can conclude that. Let's try it one more time on our own. Now the question is, are these figures congruent? So I'm going to look for a series of transformations that drop this 5-sided polygon onto this other 5-sided polygon. So let's think about things that might be, let's think about vertices that might be corresponding. So it looks like C probably corresponds with O because it's the point in the polygon that makes it concave. So if they were congruent, then C would probably correspond to O, and that makes N, because it's on the longer side of that ray that makes up that vertice, or that makes up that angle inside the polygon, N would probably correspond to B, and that would, following this down, it would mean that A would correspond to M. Okay, so let's just think about that for a second. I'm going to pause the video and write down the coordinates for all the points here, and we can try to figure out what we would do with the coordinates in order to get one on top of the other, which is always the first step. Okay, so let's first look at the orientation here. So let me just mark these with what I think it might be. This might be A prime, B prime, this is C prime. I don't know, but I'm suspecting that this is where they would be if they were congruent figures. So it looks like the orientation has changed. So from A to go to E, I would go down 2 and right, 1, 2, 3, 4, 5, 6 in the original figure, and then I go up 2 and right 6 in the new figure. So the orientation has changed. So it's either going to be a rotation or a reflection. Okay, so let me just try something out here. It doesn't, some of this is going to be sort of guess and check. What if I reflected the original figure over the x-axis, and then maybe it's a translation to the left. So if I reflected it over there, I might get something that, let's look at the coordinates here for a minute. So for A, if I reflected that over the x-axis, I would get a negative y, where A prime would be 3, negative 7, right? And then, let's see, how do I get that onto 4, 0? So I wonder, because M is negative 4, 0, so if M is negative 4, 0, then this would have had to go down, or to the left. Left, how many? 3, 7? And then this, from there to there, that would have to go up, up 7, right? So let's try it with a different point and see if we can do that. So I'm suggesting reflection over the x-axis and then this transformation. Okay, let's see. I know that that brings A onto M, but let's see if it brings B onto N. So B is 6, 11. Okay, reflection over the x-axis would get us to 6, negative 11. And then left 7 would bring that back, and then up 7 would bring that up to negative 4. Okay, since I know that's not what this is, I know that what I suggested can't be right. Okay, so again, we're just going to do a guess and check here. I wonder if I can reflect across the y and then translate. So if I reflect it across the, or I wonder if it's a rotation, because rotation also changes the orientation. So maybe it's a rotation and then a translation. So if I rotated A 90 degrees, it would become in this quadrant. let's rotate it 180 degrees. So let's rotate it 180 degree rotation would get me -3, -7. And then if I wanted to get on -4, 0, maybe I could translate it. So what would I need to do to translate? I'd have to go left 1 and right 7. No, sorry, up 7. Left 1 and up 7. Let's see if I can do that to B in order to get onto N. Left 1 would take it at 2, and up 7 would take it onto 11. So that's not what that is. I wonder if it's a reflection and a rotation. Okay. If it's a reflection, let's see if it's a reflection over the x-axis and then a rotation. So if it's a reflection over the x, that makes this, followed by, let's say, a 90-degree rotation. No, that would just be 7 negative, that would be 7, 3. Okay. Okay, so for your first exercise, you're going to have to figure out what transformation brings one onto the other. And I've tried a few for you. So I would like to see in the notebooks tomorrow what you have for transformations that brings this polygon onto this polygon. Okay?